So the last thing we're going to see is a bit on what are called periodic functions. In particular, what it means for a function to be periodic, where if we have something like f of t, just some general function, and we evaluate it at t plus p, we throw some value on there and get back just f of t. That is essentially putting that p inside of the function does nothing. We say that the function is periodic with period p, where that p is the smallest value such that this happens, and it's a fixed pattern. It doesn't just happen the one time, although I think you do have some terminology for that sort of rare case. But here we're talking about something that's a bit more repetitive, and the trigonometric functions, thanks to their circular behavior, are the perfect candidate for this, where it would make sense to think that with our functions, we would get a nice consistent period of 2 pi at the very least, because that definitely has repeats. And in fact, for cosine and sine, that is the case. We have that sine of 2 pi plus t is the same as sine of t, while cosine of t plus 2 pi is just cosine of t. So we say that sine and cosine have period t. And we'll see more about that in later sections when we talk about graphing these functions. We'll actually see what that period is and get some other terms with things like amplitude and frequency, but that's for about a week from now. Meanwhile, for tangent and cotangent, well, by the way, secant and cosecant behave much in the same way as sine and cosine by virtue of their natural reciprocal relationship. But anyway, for tangent and cotangent, in fact, we have a little bit of a nicer picture where tangent of t plus pi is equal to tangent of t, while cotangent of t plus pi is also just equal to cotangent of t. So the period for tangent and cotangent would just be the value pi. And as a result, we can use this to evaluate at some maybe unusual or otherwise awkward values, like if we wanted to find cosine of 9 pi. What we could do is take that 9 pi and split it up into two pieces, a pi over 4 and an 8 pi over 4. Not obvious why that's useful, but 8 pi over 4 simplifies down to 2 pi, so we have cosine of pi over 4 plus 2 pi, which thanks to periodicity is just cosine of pi over 4. And if there's one thing we should know for sure by the end of this section, it's that cosine of pi over 4 is root 2 over 2. But that's really all we've seen. And later on, we'll see more stuff, and we'll see more of those details, we'll see more of those special relationships, but there are quite a lot more angles that aren't quite so nice. And the last thing we'll have for this section, though it's not going to be one of these lecture-ish videos, is just a little bit on how we can get some of those non-standard values using a calculator, because that's important to know, but, well, it's not so clean for me to write on the board. So I'm going to push that off to there, and for these, we're to continue on afterwards, moving into 4.3, where we're really going to get into the behavior of our main trigonometric functions.